study about lack of memory property of exponential distribution. Now let's have a look at the statement. Let x denote the waiting time of certain event to occur. Suppose that the event has not occurred up to a time k, that is x. If x is greater than or equal to k, then we will consider another variable, that is y, which is equal to x minus k, which denotes the additional time, additional waiting time. And the lack of memory property of exponential distribution claims that the distribution of the additional waiting time, that is the distribution of y, that is y is equal to x minus k, are identical. Distribution claims that the distribution of additional waiting time are identical if the waiting time distribution is exponential, are identical with the distribution of x if the waiting time distribution is exponential. That is, probability of y less than or equal to t given x greater than or equal to k is equal to probability of x greater than or equal to k. Now let's have a look at the proof. So we have to prove that the probability of y less than or equal to k given x greater than or equal to y less than or equal to t given x greater than or equal to k is equal to the probability of x greater than or equal to t. Distribution, x follows an exponential distribution, and f of x is equal to theta e raised to minus theta x. So theta is the parameter. Now we have to find out probability of x less than or equal to t, which is equal to what? Integral 0 to t f of x dx. This is equal to integral 0 to t. What is f of x? Theta e raised to minus theta x. I took the theta outside because theta is a constant, which is equal to theta divided by minus theta into e raised to minus theta x. I have given the limits. This is equal to theta and theta gets cancelled, minus e raised to minus theta t minus e raised to 0, which is equal to what? 1 minus e raised to minus theta t. So probability of x less than or equal to t is what? 1 minus e raised to minus theta t. Now just keep this result in your mind. Now we will move on to proving the inequality. Less than or equal to t given x greater than or equal to k. So this is the left hand side of our theorem. Okay, now let's see how we will write this, which is equal to probability of, instead of y, you know that in your statement it is given y is equal to what? X minus k, right? So instead of that I will give x minus k is less than or equal to t given x greater than or equal to k. Okay, which is equal to probability of x minus k less than or equal to t. Now given something. So what is p of a given b? How will you write that? Intersection, yeah, x greater than or equal to k, the whole divided by probability of x greater than or equal to k. Now this is equal to what? Probability of x less than or equal to t plus k intersection x greater than or equal to k divided by, how can I write this? I am going to rewrite this as 1 minus probability of x less than or equal to k. Okay, which is equal to probability of, now I am going to combine this. How will I combine that? K, yeah, k into k less than or equal to x less than or equal to t plus k, which is divided by 1 minus probability of x less than or equal to k. Now this numerator, how will you rewrite that? Probability of x less than or equal to probability of x less than or equal to t plus k minus probability of x less than or equal to k, the whole divided by 1 minus probability of x less than or equal to k. Right. Now I am going to apply what this thing, that that is probability of x less than or equal to k is equal to 1 minus e raised to minus theta t in this equation. Okay, so here I will get what is probability of x less than or equal to t? 1 minus e raised to minus theta t. So instead of t, I have what? T plus k. So how will I write that? 1 minus e raised to minus theta into what? T plus k. Right? Okay. Then minus, so this I am going to give it in a square bracket, minus my next square bracket, that is x less than or equal to k. What I will get is 1 minus e raised to minus theta k. Okay, now whole divided by 1 minus, I have a 1 over here, I just wrote it, minus probability of x less than or equal to k. What is it? 1 minus e raised to minus theta k. Okay, now this is equal to what? You have to expand this and you will have to find out what you will get. Okay, now I wrote whatever I have written in the last previous step. So till here was the previous step. Now what I did is I opened each brackets and then I cancelled out some terms over here, and finally I got simple mathematics. I got what? 1 minus e raised to minus theta t. Now what is this 1 minus e raised to minus theta t? It is nothing but probability of x less than or equal to t. So you see from where we started, probability of y less than or equal to t given x greater than or equal to k is equal to what? Probability of x less than or equal to t. So it proves that it has the same distribution, and that is the exponential distribution.